Today I'll be showing solution to problem number 25. So a postal employee drives a delivery truck along the route shown in the accompanying figure. Determine the magnitude and direction of the resultant displacement by drawing a scale diagram. So first we have to draw our scale diagram from the diagram that's shown. So first, postman goes in this direction. He goes 2.6 kilometers north. Then he goes 4 kilometers east. And then after that, he goes 3.1 kilometers in this direction. The direction is 45 degrees north of east. Okay. So that's the beginning of our scale diagram. And so what we need to do is we need to determine the magnitude and the direction of the resultant displacement. So the resultant of these vectors is this vector right here, from like the beginning right here all the way to the end of the vector. So we need to figure out the magnitude of this resultant vector as well as the direction of the vector. So first we're going to find the magnitude. We can find the magnitude by using a right triangle. We can set up a right triangle. We can find the magnitude. So then that means the magnitude is just the hypotenuse of this right triangle. You can find the hypotenuse using the Pythagorean theorem. So first, in order to do that, we need to figure out what y equals the y component of the vector, and then what x equals, which is this side of the triangle. So first, we can easily find out x. Let's see. So the x is going to be 4.0 kilometers plus. So we need to figure out what this section right here is. In this section, you can just look at this little triangle right here and figure out that this section right here equals 3.1 times cosine of 45 degrees. And that's what side x equals. And then we have to find side y. Side y is pretty easy to figure out as well. So let's see, so side y is 2.6 kilometers, and then we have to add this side right here of this little triangle, and that should equal 3.1 times the sine of 45 degrees. So now we have our x component of the vector as well as our y component, so now we can plug these into the Pythagorean theorem and solve for the magnitude, which should just be x squared plus y squared should equal the magnitude of the vector. So you just plug in like the x value right here to this one, and the y value here to that one. And the result of that should come out to be 7.8 kilometers is the magnitude of the vector. And it comes to be 7.8 when you take into account significant figures. So now we have found the magnitude. Now we need to find the angle of direction. So we need to find what this angle is right here. We can find that angle by using arctangent. So let's see. So arctangent. So let's set that up real quick. I'm going to go back a few steps. So you can see right here the tangent of this angle equals y over x. So then if you want to find the angle of that, we just turn it into arctangent of y over x is equal to theta. So then since we already found y and we've already found x, so we can just plug those values in. And when you plug those values in, the angle should come out to be 38 degrees. And this comes out to be 38 degrees if you take into account significant figures. So then the final answer is, let's see. So we have to determine the magnitude and direction of the resultant displacement. So the answer is the vector is 7.8 kilometers at 38 degrees north of east. And this will be your final answer. And if you're wondering about this part right here, the north of east, really it's just like 38 degrees. Imagine these the cardinal directions: north, south, west, east. If you have 38 degrees, that's 38 degrees right there, then it's just like 38 degrees north of east. Okay.